All right, we are going to create some quadratic equations here that we need to solve. For example 1, we have a picture frame which measures 30 centimeters by 45 centimeters. So that's the outside of what I have shown here. And then a mat with a uniform width is placed inside the frame to surround the picture. So the picture itself is this part. Here's the picture. And then the mat is that border that just sits on top of the picture, surrounding it before you get to the frame. So if you have any of those in your house, you might see some photographs or some photography, or other things hanging on the wall that might have a mat in it. So it has a uniform width, which means this distance is the same as this distance, is the same as this, is the same as this, and it's surrounding the picture. If the area of the mat should equal the area of the picture, what width should the mat be to 1 decimal place? So if the area of the mat has to equal the area of the picture, then if we could find the total area, so area is length times width for a rectangle, the total area would just be 30 times the 45. And if we take 30 times 45, I believe that's 1,350. So it means the area of the mat and the area of the picture would be half of that. We're cutting that into 2 equal pieces. So the area of the picture is equal to the area of the mat. So I'm just using little subscripts here to explain. So that means that it would equal a half of your total area. Half of your total area, or 1/2 of the 1350, which would be 675 square centimeters. So the area of the picture has to be 675 square centimeters, as does the area of the mat. So we could work with either one of those, but what we need to know is what the width of the mat should be. So I'm going to let that be my variable. I'm going to let x represent the width of the mat. So if that is the case, we can either break that mat down into smaller chunks and then do the area of it, or we can work with the area of the picture. And the area of the picture, its dimensions are going to look like this. This length here would be your entire 45, but then you're going to reduce it by x and reduce it by another x, or reduce it by 2 x's. So that length would be 45 minus 2x. And the width of that rectangle, the width of the picture, would be 30, because this whole length is 30, but then again we're taking an x off of it and taking another x off of it. So the area of the picture is length times width, and the length would be 45 minus 2 x's, or x is the width of the mat, times the 30 minus 2 x's. All right, and we know the area of the picture is equal to 675 square centimeters. Now, this is not the only way to do this question. There's lots of different ways we could approach it, but this is just one way. You might be able to get there in another way, and if you want me to check it, by all means, send me a message, and I will work with you on that and see if we can come up with a yay or a nay. So I'm just going to hop through the bracket here and get what the expanded form is, because I need to get a 0 on one side and I only have x's. I'm trying to solve for x. I want to get what that width of the mat is going to be. So we'll have a minus 90x, we'll have a minus 60x, and then we're going to have a plus 4x squared. So I'm going to rewrite that in standard form, putting the x squared first. I'm going to collect my like terms here. That's going to be a minus 150x. And then I'm subtracting 675 from both sides, and I'm going to end up with a plus 675. All right, so from here I could try factoring. I don't think there's anything that will common factor out of that, and then I could try factoring by finding two numbers that will add to negative 150 and multiply to whatever 4 times 675 is, but that's going to take me a long time, so I'm going to use the quadratic formula. So my value of x will equal negative b. negative 150, plus or minus the square root of negative 150. I'm going to put that in brackets because I want to square that negative. The whole b value gets squared. Minus 4 times the a, which is 4, times the c, which is 675, all divided by 2 times the a, 2 times 4. All right, so we get a positive 150 because a negative negative is positive, plus or minus the square root of 11,700, all divided by 8. And then from there, we're going to actually break that into the two pieces. Either x is equal to positive 150 plus the square root of 11,700 divided by 8, or x will equal 150 minus the square root of 11700 divided by 8. Okay, and with the magic of technology, I now have my answers here, but I want to talk about those answers and talk about what makes sense here. So, we know x is the width of the mat. So I have x being approximately 32.3 centimeters or 5.2 centimeters. If I think of the entire width of the picture, up here, the width of the picture was 30 centimeters. There's no way the mat can have a width that's bigger than the width of the entire frame. So this is what we call an extraneous root. It's an extra root that we got, an extra answer that we got, that does not fit the domain of the problem. It doesn't make sense for what our values of x could be. So our width of our mat, so that the frame, the mat and the picture have the same area, would have to be about 5.2 centimeters. So we conclude that with our statement, the width of the mat is 5.2 centimeters. All right, we're going to move into some business applications here, but we need to define some terms. All right, some of the business terms that you need to know include revenue. Revenue is the amount of money a business brings in from the sale of a product or a service. So let's say in the summer you have a lawn cutting business and you charge every person who gets your service $30 for cutting the lawn. So your revenue would be $30 times the number of lawns that you cut, or the number of items that you sell times your selling price. So if you cut 40 lawns at $30 a piece, your revenue would be 30 times 40. Your cost is the amount of money it takes to produce a product or provide a service. And I need to fix my typo here. Magically, it's fixed. And with that lawn cutting business, you would have costs like the cost for fuel to put into your lawnmower to make it run, the cost for oil changes, the cost of actually purchasing the lawnmower, the cost of getting your blades sharpened, and so on. So you do have operating costs there. So your cost would be your number of items sold times the cost to produce each item. So you would look at that as an overall average, or you would look at that as a package. But if it's individual items that you're creating, then it's the number that you're selling and the cost that it takes to produce each one of those items. Your profit is the amount of money left when costs are subtracted from the revenue. So you take all your money that comes in, you take away all the costs that you've had to incur to run the business, and what you have left is called the profit. If you break even in a business, that means your profit equals 0. It means your revenue is equivalent to your costs. So I should put that in here as well. If you're in the black, you're making money. If you're in the red, you're losing money. Okay, so I just summarized those particular terms there. All right, for our next example here, Dharma's selling an average of 30 necklaces per week at the beach for $6. It's costing her $1.50 for materials to make the necklaces, each one, and she's done a survey and found that for every 50-cent increase in selling price, she will lose 2 sales per week. Use Quadratics to help you determine what price she should charge to maximize her profit. So, the thing that's variable here is how many 50-cent increases we would have in our price. So I've made a let statement here to represent the number of 50-cent increases in selling price. So our revenue will be equal to the number of necklaces times the selling price. So we're starting with 30 necklaces being sold per week, and the selling price of each necklace is $6. But we're going to change that. That $30, 30 necklaces is going to decrease, it's going to reduce or lose 2 sales every week. So the 30 is going to decrease by 2 X's, 2 times the number of times we increase that price by 50 cents. So if we increase by 150 cents, we lose 2 sales only. So 2 times 1 is 2. And that takes us to 30 minus 2, which is 28 necklaces. If we decrease by two groups of 50 cents, we're going to lose 2 groups of sales, 2 groups of 2 sales, which will be 4 sales, and this will now become 26 necklaces. Our selling price then is 6 plus 0.50 times x, or 0.5 times x. So there is our revenue equation. Now our cost equation, our cost is our number of necklaces that we are making times the cost of making the necklace. So that means our number of necklaces is still the same. It's still going to be 30 minus 2x from what we had above. And then the cost to make, it's $1.50 for each necklace. So that's times $1.50 or 1.5. Now, we want to maximize profit, and we know profit is equal to our revenue minus our cost. So we're going to take our revenue equation, which is 30 minus 2x times 6 plus 0.5x. We're going to have that take away, and I'm just going to rewrite the order, 1.5 times the 30 minus 2x, which is our cost equation. So this is what we're going to work with, and we want to maximize. That means we're finding the vertex. So the key word is maximize. We want to find the vertex here. So a couple of options here. Expand and simplify. Then you can either complete the square, or you can use the negative b over 2a to get the x coordinate, which would be our number of 50-cent increases in selling price. And then you can sub that into your equation for profit to get the maximum profit. But what we're really asked for is what price she should charge. And remember, the selling price comes from here. The price that she should charge comes from the selling price, or this expression. So when we find the x-coordinate of the vertex, we want to put it in the 6 plus 0.5x. So take some time, expand, simplify, see what you can come up with there. All right, so I have my solution here. I decided to complete the square. I didn't have to, but I decided to do that. I got my vertex to be at 3,144. So the maximum profit is $144, and it's when x equals 3. And remember, x is the number of 50-cent increases in selling price, so we need to increase the selling price by 3 groups of 50 cents. Now our selling price, remember, comes from here. Our selling price then, so our selling price will equal 6 plus 50 cents times 3. So 3 groups of 50 cents is $1.50. That's going to take our selling price up to $7.50. So that will maximize her profits. Now, I believe the questions in your textbook only focus on the revenue. I don't think that it needs to worry about the costs part of it. So you just need an equation to represent your revenue, which will be factored form, which then you can use your factored form to find your maximums.